Hey, my name is Chris. I'm making tutorials here on the internet currently related to AWS Cloud. If you don't believe me, you can always check out my website, 99cloud.com. Now, you might have tried to set up several REST endpoints over the AWS web interface and came to the conclusion that you actually will be dead before you've set them all up. I'm sure you have been thinking, can't I just set up all infrastructure components with code? In this video, we'll find out, so if you are interested, stay tuned. Hey and welcome back. In this tutorial, we will be building a REST backend using DynamoDB, Lambda, and the API gateway with the Serverless Framework. The Serverless Framework is a tool with which we can build AWS services programmatically. This is also called IAC, or Infrastructure as Code. Let's have a look at the agenda. First, we will learn what the Serverless Framework is and does exactly. Then we will take a look at AWS CloudFormation and what CloudFormation does exactly. Then we will look at the differences between the HTTP API and the REST API. Both are APIs with which we can build REST APIs on AWS. Then we will install the Serverless Framework. After that, we will learn how to create and deploy a serverless project. And then we will also look how we can just deploy the code of a function only. Because when we are developing, we don't want to deploy all the infrastructure, we only want to deploy the code, and that's also possible with the Serverless Framework. Then we will be configuring resources in the Serverless Framework. In the resources section, you will be able to programmatically add CloudFormation code. After that, we will be configuring the provider section of the Serverless Framework, where we can specify AWS dependent attributes. Then we will be installing the AWS SDK version 3 and ULID. The AWS SDK is required because we will need the client library of DynamoDB so that we can reach DynamoDB from our Lambda function, and we will use ULID, which is similar to UUID, to generate the unique ID for a record. And then last but not least, we will build our CRUD functions, so create, read, update, and delete functionality. Then let's take a look at the prerequisites. You will require a dev environment on Mac with NodeJS and VS Code installed. I have a video which is linked in the comment section below that explains how to do that. You will also need the AWS CLI, for which I also have a video in the comment section below. Then to test REST services, I will use a tool called Postman, for which the link is also in the comment section below. Then let's take a look at the architecture. This is what we will be building, so we will use the Serverless Framework, not only to build our code, but also to build our infrastructure services, such as the API gateway, the Lambda service, and DynamoDB. So without further ado, let's get right started. What is the Serverless Framework? The Serverless Framework was initially created to build applications on AWS Lambda, which is Amazon's function as a service cloud platform. Over time, they've extended support for additional cloud providers. The main benefit of the serverless framework with AWS Lambda is that you can create the full infrastructure as code with low effort. A lot of complexity is abstracted away. You simply define your endpoints and let the serverless framework deal with creating the API gateway, the Lambda functions, and even upload your code. In addition, there is a resources section that allows you to use traditional AWS Cloud formation code to create other services on AWS. This means you can use the serverless framework not only for AWS Lambda, but for all other AWS services too. What is AWS Cloud Formation? AWS Cloud Formation can be used to create AWS services in a programmatic way. Using the AWS Web Console to create services will get too labor-intensive if you have to create several environments such as dev, UAT, and production. You don't want to repeat yourself setting up these environments manually. With CloudFormation, you can create a configuration file containing all the services and then let AWS create them for you. This is also called AIC or Infrastructure as Code. Let's have a look at the HTTP API versus the REST API. AWS has traditionally been providing a so-called REST API, but in the meantime, they have now implemented a new version which is called HTTP API. It looks like the serverless framework team has removed the configuration option for traditional AWS REST APIs, but you can still create them if you need them, as the HTTP API still lacks some features compared to the traditional REST API. The benefit of using the HTTP API according to the serverless framework documentation is that you will have an approximately 71% cost reduction and 60% latency reduction when using the HTTP API versus the REST API. So these reasons are pretty compelling to set up the REST endpoints using the HTTP API. If you, however, need usage plans, API keys, wildcard subdomains, requests or response transformations, caching, JSON schema validation, or edge optimization, then you will be better off with the traditional REST API. If you require the code for a traditional REST API, there will be a GitHub link in the comment section below. The setup is fairly similar to that of the HTTP API. You generally just have to replace the HTTP API attribute with the HTTP attribute in the serverless YAML file, which we will look at later. Let's install the serverless framework and set up a new project directory. In order to install the serverless framework, we can use the npm command. So on the console, we can type npm install -g serverless. The -g option means that serverless will be installed globally, which means we can execute the command line command in whichever directory we are, as it will be added to our path. So let's hit enter. Okay, the serverless framework has been installed, and now we can use the SLS command line command to set up our project. So here on the console, we can just type SLS. And this will bring up a menu where we can choose what we actually want to set up. And what we want to set up is this NodeJS HTTP API. So we can just select that and then press enter. And then it will ask us, what do you want to call this project? And here I will type nodes HTTP API. Enter. Then it will ask us, do you want to log in register to the serverless dashboard? We won't do this now, so we can just type no here. Do you want to deploy now? And I will type no here as well. We will deploy a little bit later. Okay. This has now created a project directory. So we can now change into the project directory, cd nodes http API. And if we type ls, then we can see that some files have already been created for us. Let's open Visual Studio Code to look at the current configuration of all these files. So we will just type code dot here, which will open Visual Studio Code. Okay, Visual Studio Code is open. The main file with which we work with to create all our AWS services is this serverless.yaml file. So let's go through it and have a look what's configured here. So here we define the service name, which is Nodes HTTP API. We use the framework version 3, which is the most current one. Then we have a provider configured. We will use AWS, but there are also other providers which are supported. And then down here we have the runtime, which in our case will be NodeJS 14.x. And then down here we define our Lambda functions, or our REST functions, if you will. Each REST function will have a name and will point to a handler. And here you can see that this handler is handler.hello. And this refers to this handler.js file here. And then under events, we have this HTTP API attribute, which says that we will set up a HTTP API. So if you would want to use a traditional REST API, you could just remove this API behind the HTTP. And then it would create a traditional REST API. But in our case, we will use the HTTP API. Then we have the path, which is basically the URL, and then the methods that will be executed, which will be get. So basically we say when we trigger the HTTP API with the path slash, with the methods get, then we will invoke this handler.hello, which is this handler.js. And if we look at this handler.js, what we have defined here is this hello Lambda function, which will just output a message called go serverless version 3 something. So now that we know how this generally works, we can actually do our first deploy. So we will just go back to the console window. And here we can type sls deploy minus verbose and press enter. And this will now connect to the cloud and set up the services for us. So by the way, if this didn't work for you, then you might have to look if you have installed the AWS CLI, which is a prerequisite. You can find the link to a tutorial in the comment section below this video, how to set up the AWS CLI. Okay, so the deployment finished. And here you can see this endpoint URL. So we can just copy this. And then we can go into our browser. And we should just be able to paste this in. And as you can see, we get the message up here, go serverless version 3. So this is the output of our script. We have now seen how we can upload the full function to AWS. But what is if we are in the middle of coding and we just want to upload some specific code of a specific function? The serverless framework lets us do this as well. So let's just change this message to something else. So we'll just delete it and then just write, hello, this is my customized message. Save. And now we just want to upload this function. We see that this function is called hello. So that is what we will need to deploy. So let's go back into our terminal, and in our terminal we can now run sls deploy -f hello. This means minus function hello -- verbose, so that we can see a little more output of what's happening. So then we can press enter. And boom, as you can see, this was very quick. Our function has been uploaded and we are now ready to test again. So let's go into our Google browser and just refresh here. And you can see here that the message has been amended accordingly. As we want to connect to DynamoDB, let's create the configuration first to create a DynamoDB table from scratch. So here in the code, I can just go on to a new line and then I'll just paste in this code. As you can see, the serverless framework has this resources section. And in this resources section, we can write plain AWS Cloud Formation code. So everything from here down to here is Cloud Formation code. And what we do here is we will create a new resource. We will call this resource nodes table. This will be an AWS DynamoDB table resource. Then we will define a table name. So we will call this nodes table. We will define a billing method. And then we will define attribute definitions and a key schema, which will have this ID attribute, which is basically our primary key. And with this defined, we should now be able to deploy, and then it will create our DynamoDB table. But before we do this, let's add some additional things to the provider function up here. So I will just paste in the code again, and then we can run through it. So what I do here is I'll define a stage, which is called dev. You could call it dev, prod, whatever you like. So this is how you can distinguish between your environments. And what I'll also add is a region, which in my case will be US East 1. So that's the data center region you are currently in. And then we define an IAM role. So this IAM role is required to give the Lambda function access to the DynamoDB table. Without this role, we couldn't connect from our Lambda function to DynamoDB, and therefore we require it. So here we just say IAM, then we will define a role. This role will have statements. The statement will have the effect allow. And the action will be DynamoDB ****. This basically means that I allow access to all DynamoDB relevant functions. Now, if you would use this in production, then you can scale down to only what you really need. So you could say, okay, I give only permission to read from DynamoDB, or okay, I only give permission to write from DynamoDB. But in our case, we will just use this general rule, as it is quite tedious to set it up, but of course it needs to be done if you would run this code in production. And then we have this resource here, and here you can see fn get att nodes table ARN. So what this down here is doing, it hooks up our IAM role with the DynamoDB table. When a DynamoDB table is being created, it will create the so-called ARN, which is the identifier of the AWS resource. And this ARN will then be automatically attached to here once the DynamoDB table is created. So at the moment we don't have it because we don't have the DynamoDB table created yet. But as soon this table down here is created and an ARN has been created as well, then this ARN will be added up here so that our IAM role knows that this is the table that the Lambda function will actually have access to. Okay, so now that we have done that, we can actually try to deploy this to see if it works. We can just say SLS deploy minus verbose. As we had deployed before, when we deploy again, then the serverless framework will actually do an update of the configuration. So it will not overwrite the configuration, it will just update where required. So let's see how this works. We will just type enter here. Okay, and as you can see, the whole deployment has been successful. At the moment, we don't see anything else yet. We only see that we still have the same URL here. We have the hello function here and so on, but we didn't get an error. This means that the resources, so our DynamoDB table and the IAM role have been created. So let's have a look how this looks like on the cloud. If you actually wonder where you can find these configuration options, so if you wonder where you can find this and this down here, if we go into Google and we search for cloud formation and DynamoDB, for example, and we click onto this link here, then you will get onto an AWS page that describes all these attributes in detail. So here we have the DynamoDB table attributes, and here you can see what kind of attributes there are. And a little bit further down, you have the explanation of all of these. So have a look at that in case you would want other kind of attribute definitions in your configuration. Another option is to look at the configuration of an existing service, such as a DynamoDB table. So there is the AWS CLI, which is a prerequisite of this tutorial as well. And here we can run a command which will help us to see how this table is actually configured. So you could create a table through the AWS Web Console and then go into your console and then just type something like this. In this example, I will just use this notes table that we have created already. And if I press enter, then you can see that I will get all these kind of definitions that we have defined previously. So we have the attribute definitions, we have the table name, we have the key schema, but then we have mixed in also some other attributes which have been generated when the table was created, and we would just need to omit those. So this is another way how you could find out how to configure the CloudFormation code. Let's head over to the AWS Web Console quickly to see how the services look like. So we will just go into Google, and then we will go into the AWS Web Console. And here we will search for DynamoDB. Let's go on to here. And then if we click onto tables, then we can see that our nodes table has been created. So that's good. That has worked. Then let's go to Lambda. And you can see here that the Lambda function has been created as well. If we go into it, then we can see that it will be triggered over the API gateway. And here we can see the code that was added. So that has worked as well. Then we can go into the API gateway. And here we can also see that the API gateway has been created. So we have seen that all the services have been set up correctly. But what is if we would want to delete all of these services? We want to delete the API gateway, we want to delete the Lambda functions, and we also want to delete DynamoDB, because maybe we want to just clear out everything so that we don't incur any costs when developing. Or we might have some mistakes and we think it maybe can be resolved by just removing everything and then adding everything back. In order to do that, we can also use the Serverless Framework. And here on the console, we can just type SLS remove, enter, and that should be it. And this should now remove all the services that were set up previously. So let's wait until this has completed, and then we can go back into the AWS console and look if the services have really been deleted. Okay, service nodes HTTP API has been successfully removed. So let's go into the browser and back on to DynamoDB. Let's click onto tables and we can see the table has been gone. Let's go into Lambda. And here you can see the function has gone as well. And then we can go on to the API gateway. And also here, no further API available. So with one single command, we got rid of all of our functions, which is really great. CloudFormation will create a stack which has the name of our project, basically, and all the services will be attached to this stack. And so once we run SLS delete in the background, it will invoke CloudFormation to delete this stack which has all the services attached. So that is basically what happens in the background, just for you to know. In this next step, we will be going to prepare our environment to create our Nodes API functions. We will require the DynamoDB client library from the AWS SDK, which is available in version 2 and 3. The difference between version 2 and version 3 is that version 3 is modular, whereas in version 2 you would have to include the full library, which includes the full set of AWS functionality, regardless if you use it or not. So we will be using the version 3, which is the newest one. And additionally, we will install ULID, which is a library to create sortable UUIDs, which we will use as the unique ID for our records. ULID will append a timestamp, which means we can sort our records by their creation dates. That's the main benefit of using ULID over UUID. So here in the root of our Nodes HTTP API, we can run the command npm install at AWS SDK /client-DynamoDB. So this will install the DynamoDB client library from the AWS SDK. Okay, this has been installed. And then we can also install ULID. So we can type npm install ULID. Okay, this has also been installed. Then what we will also need to do is set up a better structure for our code. So at the moment, if we type ls, then we have everything in this root. But we want to put our code into the src folder, which is quite a good convention when working with NodeJS. So we can create a folder called src. And additionally, we can create the folder src/notes. And then we will put all our nodes code into this folder. So when we go back to Visual Studio Code, then we will see that we have our src directory here. And if we click on it, then we will see this nodes folder in which we will put all our code files. So now that everything is prepared, we can build our addNote function. So for that, we will add the code first. So in our src directory in the Visual Studio Code, we can right-click on Nodes and then click onto New File. And we will call this file addNote.js. And then here I will just copy and paste in the code, and I will walk through with you quickly to see what we are doing. So here we get the required functions from our SDK, so the DynamoDB client library of our SDK. Then we also import the ULID. So here we have our addNote function defined, and we will pass in the event, because in this event variable we will have the JSON body, which has the note that we will want to save. And then here we create the created at attribute, so we will just say new date, which will return the actual date. Here we will create a new ID, so we just say ulid.ulid. And that's it. It's just a function that will return this ULID. Here, this is for measuring the time to see how long it takes. A little bit further down, I also have an end date, as you can see, so that we can see how long the execution time actually was. This will be actually logged to CloudWatch to see how fast the execution went. So here we create our Dynamo client object and we pass the region, as you can see here. And then we create this input variable, which will hold the table name, which is nodes table, and then the item that we create. And here, as you can see, we will use this ULID as the ID. Then the node is parsed over this event.body up here. So this is passed over JSON, and then we have the created at, which is this here, where we just get the new date. And then here we execute the send function of the Dynamo client object, and we define a new put item command with our input. So this put item command will insert the data which we have defined up here into DynamoDB. And if there was an error, then we will log an error. Now, once this node item has been created, we actually want to get back at least the ID, but I just want to pass back the full object. Maybe we want to save another record which is dependent on this ID, where this ID needs to be stored additionally. So basically we just want to see that this record is returned. Now basically we could put the variable here equals to Dynamo client send, but we won't actually get back the object from the database. We can do this when we update items, but we cannot do it when we create items. So that's a limitation of this put item command, that we cannot get back the edit item. So that's why we define it down here. I have written some text here. So if you copy and paste it from my website, the link is in the comment section below, then you can read through this to see why this isn't possible. And that's it. Then at the end, we just give back status code 200, and then we will add this new node, which we defined here in the JSON body. And then here we have this module.exports, where we just say that this addNote function is our handler. So now that we have added this code, we will have to go into the serverless YAML file, and under functions, we will create this specific function. So I will just copy and paste this in to not bore you with coding. And that's basically it. So here we define this handler, which is our addNote handler. And then under events, we say it has to be triggered by this HTTP API. The path should be /note, and the method should be post. So we can save this. And then we can deploy and check if this actually is working. So we will go back into the console. And in here, we will just type SLS deploy --verbose and see what happens. So this will now update our stack with the added code. Okay, so this seemed to have worked. So here you can now see that we have still this get method, which is this hello function. But additionally, we have now a method post, where we have our node function to create a new node. So we will just copy this URL. Then we will go into Postman. And here we can just create a new tab, and then we can use post. We can copy in our URL, and then we can go here to the body, and under here we can say raw, and then we will just write a first node. So we can just type node double point. This is a first test from Postman. Okay, that should be it. Then we can click on to send. And this will give us an internal server error. So let me get back to you once I found what the issue is. Okay, I'm back. I found the error. Let me explain you quickly how you can debug such errors. So when we get an error such as internal server error, what we can do is we can go into the AWS web console, and here we can search for CloudWatch. So CloudWatch is basically a logging environment. So here you can see that we have this log group called addNote. And if we go into this, then down here we can see the logs that were written at the specific time. So if I go into this one, and then I can see all the logs that have been written. And here I can see error and error. So if I open this up, then it tells me that the runtime handler was not found. So src nodes addNote.handler is undefined or not exported. So that's the problem. So from that, we can conclude that we have some kind of error in the configuration. And the error was, if I go back to VS Code, that this had spaces inside and not tabs. And that was basically the error. So when you copy and paste stuff into this serverless YML file, then you might want to make sure that all of these line items are tabs and not spaces. Otherwise, you can experience such errors. Okay, now let's go back to Postman. And if I post this now, send, we will see that we get back this record. And here we can see the ULID that has been created. And then the text and the creation date. Now, one thing to note is that in version 3 of the AWS SDK with the client library functionality, you always have this preceding letters, which is basically what kinds of attribute the attribute is. So S stands for string, I would stand for integer, and so on, or N stands for number. I'm not sure anymore, so you just need to look it up. This isn't the case in the version 2 of the library. So this is a little bit confusing, but it's just per convention. That's how Amazon has defined it. So if you would read this into an object, then you can access it by note.s. So note.s would then return this string and not note, because note itself is an object that consists of these two values. Okay, so let's see now if this entry has actually been created in DynamoDB. So we just go back into the AWS console, then we can go to DynamoDB. And then we can go on to tables. We can select our nodes table. And if we click on to explore items, then we will see down here that this item has been added. Let's now add our next function. The next function will be the fetchNotes function that will list all our nodes. So we go back into src and nodes, and here we can right click on it, new file. Then we can say fetchNotes.js. Then here I will just copy and paste in the code. And as you can see, the code is fairly similar to what we have had before. So we have the Dynamo client, which we want to get. And here we will use the scan command. The scan command is a command that will list all the records which are in the specific table. And we again get it from this AWS SDK client DynamoDB library. Then here we define the function again. And as we only want to list all the entries, we don't have an item that we specify in here. We only define the nodes table, so the table name. Then down here again, we have this await DynamoDB client.send, this time with this scan command. And here we also add this input again. But here we have this data constant in which we will get all our values into. And then down here we will display this constant when we return the record. And here we have data.items. So packed into this items, we will find all the records. And then if there is an error, we console.log out the error again. And I don't need to explain the rest. It's fairly similar. Next, we will add the serverless YAML configuration again. So I will just copy and paste this again. And here we need to make sure again that these are all tabs. So I'm just making sure that this is not causing any additional issues again. Save. That should be it. Then we can hop over to the root directory again on the terminal window, and here we can run sls deploy ---- verbose again. Okay, so as you can see, our fetchNotes function has been added here, and here we also have this endpoint defined, so we can copy this again. Then we will go over to Postman, add a new tab. This will be get, with just paste the URL, click send. And again, we get an internal server error. So let's have a look what the problem is now. Let's go back to CloudWatch. CloudWatch. Then we will go into the log groups again. And here we have this fetchNotes function. Let's see what the problem is now. And again, we have the same issue. So let me check up on this and get back to you again. Okay, I found the issue. So the issue is here. This events is tabbed one too much. So we will need to tab this back. And we can save it. So this is really tedious. It's really tedious, but that's how YAML works. So what can we do? Okay, so we've corrected that. So now we can run SLS deploy again. Not sure what this problem is again. So let me get back to you again. Okay, I found the error. The error was that I didn't actually save the fetchNotes.js file. So just make sure that you are sure that you have saved the file. If you didn't save the file, it will have like a dot up here instead of the X. That means that you still need to save. So now that it's saved, let's try that once again. So let's deploy. Oh, this wasn't it. So let me get back to you again. Okay, I found the error. The error is that it's still tabbed incorrectly. So you need to be really careful with this. And that's a little bit of a pain, to be honest. So we will just tab these things right. And hopefully this time it worked. So let's try this again. Okay, that looks better. Okay, so this has run through. So let's check if this is working now. So let's get back into this get function. We can click send again. And as you can see, we can now see this node that we have previously added. In this next section, we will create the fetchNote endpoint, which we can use to fetch a specific post by its ID. So let's click on this notes again up here, then right mouse click new file, and we will call this fetchNote.js. Then we can paste in the code again. So for this, we will use the getItem command. The rest is the same. We define the Dynamo client again. Then here we will specify the table name again, and we will pass the key, which is ID. And up here, we get this ID from the pass parameters. So we will pass the ID as a pass parameter in our URL, and that's how we can get this pass parameter back. And then we will execute this getItem command with the input again, and the data will return this specific item. And then down here again, we will return this specific item. And the rest should be fairly familiar to you, so I will not explain it in more detail. Now we have done that, we will go into our tedious file again, which is the serverless.yaml file. And here I will paste in this fetchNote configuration. Then we will need to check again that there are no spaces. Okay, is the indentation correct? It looks more or less correct, I think. So we save this file, and we will also make sure that we have saved the fetchNote.js file. Good, then we can deploy again. Okay, so we have the fetchNote function defined here, and we have this fetchNote endpoint, so we can just copy it again. Then we will go into Postman, then we can create a new tab. This will be get, we can paste the URL, and then we can get the ID from our fetchNote endpoint. So I can just copy this. And then I will go over here, and then I can paste this as the ID we want to look up. And that should be it. So let's see if we get an internal server error again. I hope not. I hope this time it worked actually out. So let's see, send, and let's hope for the best. Ah, yeah, fantastic. So no further error, and we got this node back. Let's now add our updateNote endpoint. This was a little bit more adventurous, but I will explain you once I have added the code. So here under nodes, we can right click again, new file. This file will be called updateNote.js, and then we can paste the code. So the code looks pretty common up here, but there will be some differences a little bit further down, which I will explain to you. So here we get the node over the JSON body, then we will get the ID through the pass parameters. We did that as before. We defined the DynamoDB client, but then here under input, you can see that we don't define an item as we did before, but we use this update expression and expression attribute values attributes. So this is basically a different way how we can structure our DynamoDB queries. And it seems that with this update item function, we have to do it this way. We don't have the possibility to just define an item as we did with most of the other functions. So this update expression looks a little bit SQL-like. So we say set note equal to $n, and this $n is a placeholder for this $n down here, which is a substitute for the note variable, which we defined up here. So here we basically say set the note attribute in DynamoDB to our updated note. And down here, this return values specifies that we want to receive back all updated attributes. So these attributes will then be returned in this data variable here when we execute the Dynamo client send with the update item command and our input. So this is a little bit inconsistent, but AWS doesn't seem to offer another way. And it was a little bit difficult to discover that it only works this way, as the documentation in itself isn't very good. So if we go on to the update item command input, we see what attributes are supported over here, but we don't really have examples that explain how to develop it, or that item isn't working. So even if we go back and look at the update item command itself, we only have very limited information. And I think the documentation could be a little bit better here and have some examples. But that's what AWS provides, so what can we do? Let's go back into the code quickly. So down here we have this const data where we get back the attributes, and then down here you also see a difference. So before we had data.item here, which returns the item, but here we have these attributes which are returned. So this is also a little bit different. And I had one annoying error. So when I go back onto CloudWatch, I always got this error, cannot read property 0 of undefined. And it took me about 1.5 hours to actually figure out what this is. And what it was is, if I go back into the code, up here, the code was looking like this. So I just passed the note down here without specifying the type. So I didn't specify the type down here, and this is why I got this error. So if you get this error, then you know that it most likely is because you didn't specify the type, which means this one means it is a string. Okay, now that we have that out of the way, we can go into serverless YAML again and then add the configuration for our updateNote handler. Here we will have to ensure that we have only tabs and not any spaces. Otherwise we will receive another error again. Okay, that looks good. And then we can go into the terminal and type SLS deploy, which should then deploy our code. Okay, the deployment has completed, and up here we have this put method, so we can just copy this URL. Then we will go over into Postman. I have specified it here already, so let's make a new one so that you can see what happens. So this is put. I will just paste in this URL, and then we need to replace this ID. So if I go to the get function again, then here, from here I can copy the ID and then add it here. And then we will also need to have a body. We will define it as raw, and in here we will type note, double point. This is an updated note. Okay. And if we click onto send, then we see we get back the updated note. So we know that this is working. And if we would go back to the get all function and update this, so here we can see before it was, this is a changed note. And if we update, this is an updated note. So you can see that this has actually changed, which means that our update function is now working correctly. Let's now add our last endpoint, which will be the deleteNote endpoint. So same as before, we right click onto nodes, new file. We will give this the name deleteNote.js, and then I'll just paste the code again. So here we get the ID from the pass parameters again, and then down here we just define this key where we pass in the ID. And that's basically it. And then a little bit further down, we just pass back whatever is coming back, and that's it. So basically we just need a status code 200, and if we have that, then we are happy and we know that the node has been deleted. Okay, then let's go into serverless.yaml. And here we will need to add the configuration. So I'm just pasting this in again. And then we will need to make sure again that we only have tabs. Okay, that should be it. Then let's go here and type SLS deploy. Okay, deployment is finished. So we have this delete method, and we can just copy this URL again, go into Postman. Here we will add a new tab. This will be delete. Then we add the URL, and here we need this ID again, which we can get from one of our get methods. Then we will add this ID here, and that should be it. We don't need to add anything in the body. So if we click send now, then we will see that we get back the status code 200. Here we have 200 OK, which means that the record should have been deleted. So if I go onto the get method here and I click send, then we get an empty array, which means that the record has been successfully deleted. And with this, we are at the end of this tutorial. If you'd like a video that builds up on this one on how to add authentication, please leave a comment so that I know you're interested. If this video was valuable to you, please give it a like and consider subscribing if you want to see more content like this. You can also check out my website, 99scloud.com. Have a good one and see you in the next video.